So static routing is something where your network administrator will update the remote network information to its router so that a router will helps to forward the packets to the intended destination, isn't it? To the intended destination. Let us think of this would be your organization, and you have all your LAN network this connected to our router. And if you need to forward the packets to either this network or this network, where that information I should update in the routing table of the router, right?
Hello, sir.
And how this, yes,
Hello, sir.
that is,
ಸರ್ ಅದು
tell
ಸರ್
me.
ಭೂಮಿಕಾ ರಾಣಿ ಸರ್ ಮೈಕ್ ವರ್ಕ್ ಆಗ್ತಿರ್ಲಿಲ್ಲ ಸರ್, ಅದಕ್ಕೆ ಈಗ ಎಕ್ಸಿಟ್ ಆಗಿ ಜಾಯ್ನ್ ಆದೆ. ಆಗಲೇ ಕರೀತಿದ್ರಲ್ಲ ಸರ್.
Okay, Bhumika, you call me after this class, okay? So you are the one of the
ಓಕೆ ಸರ್.
placement secretary, right? You're placement secretary, right?
ಎಸ್ ಸರ್.
Okay, and who
ಯಾ
is
ಸರ್.
from boys side? Who's from boys side?
ಎಸ್ ಸರ್.
Who is from boys side?
ಅನುಭವ್
Another
ಸರ್.
one, placement
ಅನುಭವ್
secretary.
ಸರ್.
Anubhav, Anubhav only.
ಅನುಭವ್ ಸರ್. ಯಾ ಸರ್.
Okay, okay. So you call me after this class, okay?
ಓಕೆ ಸರ್. ಓಕೆ ಸರ್.
Okay. So when we were discussing in uh, static routing, a network administrator uh, of any of the organization, they should know and some information about the remote network, so that if they know about this information, routing information about the remote network, routing information. What do you mean by routing information? Something they should know about what is the network. At least they should know about the network address and the subnet mask. Okay, these two information they should know, so that so then you can apply, so you can update this information in its router, so that this router will help to forward that package to the intended, so to that specific remote network. Okay, if that if that is happened, so that you will be having a reachability from your network to from here to the any other remote network, either from here or to PC2 or PC3, whatever. What if you don't know about this remote network? Okay, so we don't know about any of these things, network address or subnet mask about remote network, then how you are going to reach the other networks? Let us you can think of. Would you think we will be using a static routing in all whoever they have connected to network? It's not at all actually. So we use something called dynamic routing protocol. Okay. So we don't want to update any of this information on router. Instead, the router will have some protocols. Based on that protocol, they were able to learn about this remote network automatically by itself, or automatically or by itself. Okay, the router will be able to learn about this remote network by itself. Okay, by using, if you would use any of this dynamic routing protocol, so where a router will establish a path or a route to the destination network. Okay, I'm not saying it could be, so from this network I would say this would be the destination because it would not been connected here. So which are all the remote networks were there in a network, typical network. So where this dynamic routing protocol will helps us to find the path to each of this remote network by itself. Okay, or by automatically. So this what by using of this dynamic routing protocol. Okay, so when we use this dynamic routing protocol, so before that we should understand there is something terminologies we used here is what is called autonomous system. Okay, autonomous system is something what I would say. I'm not going to tell you the formal definition. Instead, I tell you so what I would understand and what I knew. Okay, autonomous system is actually a group of network where this group of networks will have a common administration. Okay, that is what I would call as one autonomous system. Okay, so then I would say your internet would be having a number of interconnected of number of autonomous system. Okay, this autonomous system. Okay, this means autonomous system 1, autonomous system 2, autonomous system 3. Okay, so in the last classes we were talking and we were saying this as a network, and now we were something saying as autonomous system. Okay, okay. In the last we said, sir, you only said this we say a network 192 one something network. This would be another network, and this would be another network. Now I would be saying, so this I would call them as autonomous system, and again I would call them as this as another autonomous system, and this would be another autonomous system. Okay. So what actually means? So is actually we should supposed to call them as autonomous system when this network will big in number. Okay. So big in number, I would say your Infosys network, I would call the whole network. Okay, belongs to one autonomous system. Okay. Our SJC, JSS network, let us say in Mysore, Bangalore, in Noida, whatever we have our institutions, and if all these networks were connected and having common administration, yes, it's supposed to be under comes under the ownership of JSS, right? Having a common administration means sitting at here SJCE, if I would able to control the JSS AT Bangalore network and as well as what we have in Noida, so then I would call this together as one autonomous system and having in common administration, which is at SJC. Okay. Similarly, Infosys, what we have, and this would be spread across throughout the globe. And if all of them were connected, interconnected, and if I would able to communicate from one network at one location to another location, probably all of this network might have in common administration. And yes, obviously it is in common administration. I call them as one autonomous system. Okay, if you look at and you could ask like, sir, so whatever the connection, if I would take to our home, would I call because it is a network and it's having an administration by me? No, it's not by you. It's actually administrated by an ISP, right? So I would call ISP who are giving a connection to each household. Then I would call them as one autonomous system. Okay, could be your Estel would be one autonomous system. Might be taken service from Airtel. Okay, and same similarly there might be another franchisee. I would call them as Act or something. I don't know. Probably it is not exactly, but I'm giving an example that an Act service provider, they would also give this fiber connection, and typically I should call them as an autonomous system, isn't it? Understood? So there might be an n number of networks, and each of those networks having in common administration, we call them as autonomous system. Okay, why I'm trying to explaining in detail about this autonomous system here? Because we would be having a different dynamic routing protocols within an autonomous system and between the autonomous system. Okay. Okay. So first we'll understand what are all okay, how you can categorize like listed out this dynamic routing protocol based on either intra or inter. Okay. So we would be using to update this routing information to each of these router within the autonomous system. We call them as intra AS routing protocol. Intra AS routing protocol. And another one is if a protocol which helps to update or forward and receives the routing information between two different autonomous system, and that we would call them as inter AAS routing protocol. So there were two types of routing protocols are here. So one is intra AS means a routing information would be exchanged within the autonomous system. We would call them as intra-AS. And if the routing information, if that would exchange between two different autonomous system, I would call them as inter-AS routing protocol. So we will discuss the theory and some how you'll find and how this routing information exchange everything in the theory part, especially in your fourth unit. So let me explain that how that would be practically implemented and how to use them. Okay, you should understand the concept, but the complete theory we will again look back in your fourth module when I am explaining about it. Okay, so in intra AS there were three protocols majorly we have in intra AS. Means intra AS within the autonomous system. Okay, so there were three. So the first one is RIP, routing information protocol. The next one is OSPF, and the next one is EIGRP. Okay, EIGRP. Okay, RIP stands for Routing Information Protocol. OSPF stands for Open Shortest Path First. EIGRP stands for Enhanced Interior Gateway Routing Protocol. So these three routing protocols they were majorly used in intra-AS routing protocol. Means within the autonomous system, we wanna use these three routing protocols for configuration for configuring router for the help of this dynamic routing exchange. Okay, dynamically routing exchange. Okay, and each of this has advantages as well as disadvantages. So you should decide based on your scenario, network scenario. You should decide which protocol I should use. So by understanding this, each of this and functions and its nature, so where you would have a decision, well, means you should get a capability that given this network, which routing protocol I should use. Okay, but whatever we do this experiments, probably we would going to take a limited network like topology. Then anything if you would use that could fine. But what we will try to understand its features and its advantages. Probably in real time, if you are going to work, so you should know how which protocol I should be used to configure on those. Okay. Okay. There is another routing technique is inter-AS between the routing AS, so between the autonomous system. So only one routing protocol we are still using, and the complete internet is completely depend on this routing protocol is BGP. Okay, Border Gateway Routing Protocol. Okay, BGP, Border Gateway Routing Protocol. Without, if you don't have this protocol, then there will be no concept of internet. Okay, the complete internet is running on which routing protocol means it help of this protocol, which is BGP. So this protocol is the only one protocol we use, and that too between two different autonomous systems. Okay, so this is a background about this RIP, and you should know why we were studying it. Okay, and let me explain how this RIP could be used on this network. Okay, and this is very simple, and even what we were doing on static on the default routing, probably we not be knowing about this information. You just need to enable that routing protocol on each of this router, and even that's very simple. Okay, so in this lab, what we were mainly doing, the first way of configuring is RIP, and that to default on all these routers. Okay, so we just enable this RIP on each of these router. So that is what the first scenario A. So by using this classful addresses, so which is /24/24/24, we will come to that what is classful network and not classless classful. Then there is something we were using a subnetted in a classful network. Okay, this if you would see. So this is the first one. If I would go to the next one, okay. So here I can say that here we were using a subnetted one from a classical network. Okay, with the subnets and between the classical networks. Okay, it would also the same. Only the change is I have to change this address. So which I would used here. Okay, and the rest the configuration will be the same. Okay, and another one is we were using What is the last one is a part of a network we will be using RIP. So this complete network we will use RIP, and this part I would be using static and the default routing. So what we did in the initial labs, static routing and the default routing. From here to here it is default, and here to here it is static. So why it like this? Let us think of this part of network would be our SACE network. Okay, from here, one link, a serial link would be connected to where our ISP router. This I would call them as ISP. You can see here itself, they will mention something like internet. You should assume this would be an internet network. So they, you don't think that they would only connect it to one network. They might have an N network, but for our understanding, I only took only one network. Okay, and most of the time the way they were configuring between our router and to that ISP router is from the ISP router to our router, it is always be the static routing. They will not use any of this dynamic routing between our router and the ISP router. Why? So I will tell you after this, like when I'm explaining about this. So why they will not configure between this and this a dynamic routing protocol? So why they use commonly use this configuration? Means from ISP router to our router, I used static routing because so they are the one ISP are the one they were assigning the IP address to our router, right? So when I'm taking the connection, they will give the public address, public IP address, and they will give the subnet mask and they will give the DNS address. These three things they will be provided not only to our organization. If you even take the connection to your home, they will give all these three things. Okay, and what the way they were configured from their router to our router is static routing. Okay, static routing to this address and the subnet mask. The next stop would be the this one only. Okay, from here to here, from our router to ISP, it should always be connect like configured with the default routing. What do you mean by default routing? There is a type of connection. It is also static routing itself, but I will not define a proper network address and the subnet mask. Instead, I will just use these addresses, and this will always result for this default routing only 0.0.0.0, and the subnet mask is also 0.0.0.0. Okay, this is the network address and this is the subnet mask. What actually this represents, if any of the network address which is comes to this router, if you would have this entry, it will ignore this network address and as well as this subnet mask, and whatever the next stop address that you will define to it, it will simply forward. Okay, so that is what this default entry is. Because what is the example I can give in our SAC? Would you think all of them will use google.com? Okay, it's not exactly right. Probably somebody might use yahoo.com, or somebody might use some other search engines. Okay, so what will happen if that to send to that particular each Google and Yahoo, this router should have that entry in its table because it has to forward it, right? So it will not keep all those entries because do you think only few of these networks will provide this? No, there were so many networks. So most of like and every network, what you will do, what your request you will send, every that to that network, you should have that network information in this router. So if you think that I have 4,000 users in my network and each of them will try to use or trying to connect some other different network, and how many network entries must have in your routing table? 4,000 entries, isn't it? And obviously it will take lookup software lookup to send that packet, because each packet as it sent to a router, it will check its destination and you look its routing table and it will send. This is not it's doing for one packet, it is doing for every packets. Okay, you think of what was the time that would be needs to inspect each packet, and what was the time it needs to look up its routing table and to take send. So there will be lots of delay might be involved, so that what we do instead of maintaining, and even that very difficult, because the routers will always having some restricted amount of memory, limited amount of memory. So maintaining that huge database quite consumes a lot of memory. If that consumes a lot of memory, the other process may get delayed or get lagged. Okay, what we do in order to reduce these entries in its routing table, instead of having all those entries, we'll keep maintaining only one entry, which is default entry. So what if you maintain default entry, your ISP will maintain all such entries so that ISP will send that to a particular destination. So that is what's the idea. So you can also ask why ISP if they maintain, does that will not affect that ISP router? So it is always like whatever the router we purchase, probably that will be having some like which we will gonna purchase it. It will not too high cost one, but whatever the ISP will purchase, they obviously they should go for an higher version. Everything is something extra. Whatever the processing could be, think of memory, everything they will go for higher version. Then only they will give the provide this sufficient services like quality of service. But our is not router is not intended to that, right? Because is only one thing. I connected our network and I connected to ISP, but ISP will not that case. They would connect it to n number of routers customers, and they should provide all that service like lookup or providing all this service to each one of them, right? So that is the another scenario. So I'll just explain you from the first one and the last one. Probably you should do the middle one by yourself. I think to follow that, I think it's given each step by step. After you did this experiment, everyone should write the one paragraph interference and telling it what is the advantages of this routing protocol and some theory about this protocol. And this was the things you should do it in this learning objectives for this. Okay. So if you would see here, the same network has been built and the same IP addresses were used. Okay. So what was the preliminary thing which is already done in this topology is, so we were assigned an IP address, we connect them. So we used to take all these routers and whatever the necessary things we need, and we connect as it is, and we assign these IP addresses to each of these devices, and you know how to assign it, right? On this host, if I click on this, and I also explained you about CLI command how to use it, right? I just assigned already to this gigabit Ethernet 0/0 to this interface. I'll just show you how to assign it one more time by using CLI command. Okay, so I'll just remove it. I'll just delete this IP addresses which I assigned. I'll turn off. I'll go to CLI mode and I'll just explain you how to do it. Okay, from the initial step, from the user mode. Okay, so this is what when you enter to CLI command, you get this initial thing, and if you enter, you'll see you are in user mode. Just give enable, and you know how to change from config like privilege mode to global configuration mode by using config terminal. You see configuration. You are in the privilege mode, sorry, global configuration mode, so that you can configure. Now in this router, I should configure this interface. Okay. To that, I should use a command called interface followed by the name of that interface. Okay. So the name, you know that, right? Gigabit Ethernet and followed by the 0/0. Okay. So you will get to know. So I cannot see here, but from your software, I think you would see what was the label of this interface. Okay. It is gigabit 0/0. Enter. After you give this enter, I think you would see this would change to that particular interface. Okay, in particular that interface, now I am in configuring. So what you will configuring here, IP address, IP address, and the IP address to assign this interface 1.1, followed space, next followed by the subnet mask, enter. So this command gives is assigned an IP address to this interface. And if you see that interface still in downstate, downstate means you are not enabled it logically. So I'll give a command like no shutdown. If it is in shutdown state now, I should turn on it so that no instant in front of it. It means you logically turn on. Okay, after you keep that command, you can see here this will turn on to green. Okay, this is a very simple thing. And similarly, you do the same thing. If after this, if you see you're in that interface itself, give exit command. It comes back to the global configuration mode. Then if you want to configure this interface, give this interface followed by that interface name, enter. So then you can check all these things. Then you can give the IP address, then followed by the IP address and the subnet mask. Then no shutdown. So this I already given, so that just exit it. I think one, if I give one example, I think that would be enough to do the same thing on all others. Okay. On every other routers, do the same thing so that you will be assigning an IP address to the CLI command. So this is the way we were doing configuration in this router. But I am directly on here. But how you'll do in real time? You'll connect a console cable or take a telnet to this PC and then you will configure. But initially, you will not do the telnet because first time you have to enable the telnet on this router, right? You should use the console cable itself. Then you have to connect to a router and you have to configure. So if your class would be in offline, probably I would have shown all these things, how to connect and how to configure and how to enable and all those things. Since I'm trying to telling that what we do in real time as well, you just try to visualize it. Okay. Okay. After this, I have to enable. You can see this command here. What we should do after assigning all this table, assigning an IP address, then we have to enable this routing protocol. So what is this enabling of routing protocol is very simple. Okay, I'll just open this command, this interface, and I'll show you. I use set of commands. Okay, just write it down. Router RIP. I'm on this router. I'm on this router now. I am on this router and CLI mode, CLI, and I enabling this RIP on this. When I enabling this RIP, I just wanted to tell you on this router which are all the networks were connected. So this is 1.0 and 2.0 were connected to this router, right? That this addresses I just wanted to update on this routing protocol. So how to do it? So router RIP, when you enter it, you can see this would change to configuring this router. So the global router, the global terminal of this router is now get configuring with this RIP. Then I just wanted to define so which are all the networks are connected. So and you should not even give the subnet mask and it is optional. This router, what is the network? Network followed by the network address, the major network ID you should give. It is 1.0, enter, and another one is 2.0. Just remove this 2 and enter. Then exit. That's it. Okay, that is the only we should do in RIP. And the same thing I'm doing on all other routers. Okay, I'll go here. I'll go to this router now, and I'll go to CLI command, and I'll just go to enable configure terminal, then router RIP enter, then I just say network, okay, network 192.168.2.0. One is this because this router also connected to this network. I'll show you. This router is also connected to this network and 3 dot network, this network and this network, 4 dot network. Okay, that I have to advertise here. I just have to update it. Network, that is the one, and another one is 3.0, enter, and another one is 4.0, enter. That's it. Exit. We give exit. Okay. Then I will come here, and if I get here on this router, and which all the networks are connected. One is 4 dot network, another one is 5 dot network. So that I have to update here. From this router, I'll go to CLI mode. CLI mode. Here enable, then configure terminal, then router RIP, then enter, then the network 192.168.4.0, enter, then the 5.0. Another one is 5.0, enter. Okay, that's it. If I given after this command, okay, After you gave this, okay, I think if I check the routing table I have to check it, right? So what do you mean by routing table? So it what all the information this router will be having, routing information. Do show IP route is the command to check the routing table of the router. IP show IP route in privilege mode. If you are in global configuration mode, you should use do in front of it. Okay. Then you get enter. After this, if you give enter, I think there would be three routes, which is R. Okay, this route, and this route. You are learning from, you are getting automatically from RIP protocol. We can see 3 dot network, 4 dot network, 5 dot network. Because this router, it doesn't know about these three networks, right? This router, it not knowing about this network because it is connected here. And it is also not knowing about 4 dot network because it is connected between this. And also 5 dot network, it is connected to router 2. This is learned by RIP. Okay. Let before that, what you should understand what is called RIP, right? So when you enable this RIP on each of this, okay, what will happen? This RIP will be running with three steps. The first one is initialization. The second one is sharing. Okay. Second one is sharing, and the third one is update. Compare and update. Third one is compare and update. So this is what is happening here. Okay. So initialization, that is what I just did right now. I just go to that RIP and I just initialize which are all the networks were connected to this router. So that is what initialization. Okay. On every router, I did initialization by defining the RIP router and I given the network followed by the network address. Okay. So the next one is sharing. So after you initialize, this complete router will go and share its routing table with its neighbor. Okay, to its immediate neighbor. Okay, and this router would also connect it to this neighbor so that it will also share its routing table. As it shared its routing table, if you see what would be the routing table here, is actually it will consist of 3 dot network which is connected here, and it will also taken 4 dot network because it is connected here, and it is also 2 dot network. Okay, it's connected here. And as it compares with this routing table, R1's routing table, this routing table, R1, this is R2, this is R2 table, and this is R1 table. R2 will be, R1 will be consist of what? 1.0/24, and it will consist of 2.0/24. As it's compared here, if you would see 2 dot network is there, but 3 dot 4 dot is not there in R1, and 1 dot network is not there in the R2. So this will be updated to R2 saying that the next stop would be this address. I have the network info. I don't have the network information on this 1.0/24. So I will update and I will keep this be the source from you. So that will be updated /1/24 and will keep the source as R1. Means if any of this network, either 3 or from here, if any of the packet arrives at here to 1 dot network, it will simply send to R1. So R1 will knows where it is because it is locally connected to its router. Okay. Similarly, has this R2 set with here, in R1, it doesn't know about 3 dot network, 4 dot network, and these two network will be doesn't know about by R1. So that will be get updated. Similarly, after this, if this would share here and this would share here, again this will update. And forwarding of its routing table, it happens every 30 seconds. Okay, every 30 seconds, there will be periodic sharing of information between its adjacent neighbors, adjacent routers. So, and again, it will go to the each step. Okay, the next step, compare and will update. There will be two types of updates happens in RIP. One is periodic updates and other one is triggered updates. Triggered update means whenever is there is change in a network, by that time it will send an update. That's it. But periodic update is something for every period of time your router will gonna share its routing table to its neighbor. Either it will change or even not change, it will update to its routing table. Like say share its tables to a neighbor. So this is the one thing. Okay. So what here is, it will not only define the routing like routes to the unknown networks, it will also calculate the least path, least distance to that network. Okay, but if you would see here, I would have only one route to reach this network. It should go via like this one, right? If I would take A, this would be B, and this would be C. So if I want to communicate from this to this, it should only go via router A and B and to C, and it will go to next PC. What if I would connect and connection between A and C? What is the way that the packet should go from here to here? It should go from ABC or it should go from AC. Which path it should select? The least path, right? The least distance. If I say if you want to go from your like from Mysore to Bangalore, how you will go? So many ways you can go. One is from Madhur to Bangalore, and another one is from Kanakpura to Bangalore. So which one you will select? Somebody will select to go via Madhur to Bangalore because the roads were nice and you can reach. Somebody will go from Kanakpura to Bangalore because the distance will be less. Like if you would think of this would be 150 kilometers, and if this would be 140 kilometers, which one will choose? Somebody will choose 150 because the roads were good. I can get reach Bangalore. But if you would think of somebody will choose 140 because the Kanakpura road, because that will be distance will be less. I don't know whether you would reach earlier than this or may takes longer. But in RIP, that is what I will discuss that later. Which path I will gonna choose it. RIP, to choosing the best path, it will gonna use a metric is what we call op counts. So because we know that we already discussed it. So in a network, the distance was measured in terms of op counts. So in RIP, this was the metric we used to find the shortest path to the any of the destination. How many hops here from this source, from this to this network to reach from this to this? If I go via this way, is two hops. From is one hop, and again is another hop, right? Two hops. So from ABC, I have how many hops to reach the destination is two hops. But here, if you see here, it is only one hop. So according to our RIP, which path they should use from A to C means this is one hop, so that the packet should go via this R1 router to R2 router directly. Okay, so just that is all. I'll just demonstrate you now. You just look at. I will not do anything. First, I will show you in the simulation mode. Okay, in the simulation mode. Okay, in simulation mode, I'll just create a packet, and that should send from PC0 to PC1. Okay, this is what I just send a keep capture and forward. Since I am doing this very first time, first it has to resolve an RIP. Means this PC would know what is my gateway IP address, but it doesn't know what is the MAC address of it. So first it will resolve it with the help of RIP. You can see that would also in this event list. Okay, then it will get back this address. Then it will now send an ICMP packet. ICMP packet that will send here, and here it will check its routing table and it will send to a next router. Then it will send to this router. Then it will send here, because again from here it has to resolve the IP address of, sorry, MAC address of this PC, right? Then it will send an ARP request. It will resolve now. After this ARP, then it will send an ICMP. Okay, so let me do it later. Okay, you can see some of the packets of RIP here means for every 30 seconds this will be exchanged with its neighbor. Okay, I think that would be lost. I'll just delete this event. Since I'm doing it very first time, it will happen like that. Go with another time. Now you would see ICMP has been sent, and it's sent here, and it will send here, and it will send here, and it will send here. Then it will send here, and it will come back. Okay, I have not done anything. I just simply enabled the routing, dynamic routing protocol that helps to route a package to any of this remote network. Even you can communicate from here to here. Okay. So what if I would add one link between these two? I just had one link between here, and I'll show you how this automatically change its routing path to this. If I would add here, and I will use some other network. Okay, I'll show you how to configure it. Okay, I'll just use the same how I did the gigabit 0/2, and I use some other network. So IP address 192.168.6.1. The subnet mask is this, and I say no shutdown, no shutdown. That's it. Okay, and here this side I would use interface gigabit 0/2, then the IP address 192.168.6.2/255.2.5, and I will say no shutdown. Okay, that's it. And I have to uh, advertise this in RIP, right? Router RIP. Then I would say another network being connected here, which is 6.0 network. Enter. Okay, you know that, right? What previously I did, I now added that network here right now. So that I will again advertise in router RIP. Okay, okay, and again I will give you the same thing. I will do it here as well. Router RIP. Then the network which is newly connected is 192.168.6.0 network. The network address of that right here. Then exit. Okay. So now if I check which way that should go, whether it should go like this or that, whether it will go like this, we'll look at it. Okay. We'll take a packet and we'll capture and we'll forward, and we will do this inspect of this packet, how it will transfer. After it comes, it will see how it's going. It will not going in this way, it will going in this way itself, because so there will be two paths are available to reach this remote network, but among them your RIP will be finding which is the best path, and how on what basis they are finding. They were finding based on the op counts. Okay, from if in this way if I would go, I will be having one extra hop, so that I will find this path, so that my distance will be reduced, because in any network how fast you will reach, that will matters. That will be only we will account it, right? Means how you will find which network will be good, how fastly you will able to access the internet. You will say that that network is very good. One way you would say, because nowadays if I ask anybody uh, how they will gonna measure this network performance, they're gonna measure them the data rate, the how fast I can access the internet, how fast, because even the voice call today is all on the packet based network, right? It is not on circuit switch or something what else. Okay, they will not gonna measure them how many times the call drops will happen. Even that will also counted, but most of the time, since we were in internet era or whatever, we do everything on internet, they will, so most of the students or the people who are young, they will want to measure them based on their exchange data exchange rate. Okay, so since that, then you should obviously find the distance, right? I just said if this would be Bangalore and this would be Mysore, either you can go via Madhur and that way, or you can go via another way. The mainly the RIP will be see the distance, which will be the distance is less. I'll choose that to go far. I'll choose that route to forward all my packets to that destination. Okay, and this automatically done. Okay, if I delete this, if I shut down this piece like interface gigabit 0/2, enter, and if I shut down this interface, okay, if I see this link is down now, and still I would able to reach, means automatically this will change a path. This will act as a secondary now. This will be primary. If whenever two paths were find, one will be primary and it will always use that primary to send. If that primary will fails, it will use the alternate path to send its routing. Okay, forward that packet. You can see it will go via this. Still, I would be able to reach that destination. Right. Again this comes up. Again, it will learn this algorithm and it will find it, which is the shortest path. Okay, it will find it, which is the shortest path. Okay, let us have some information about this in this Geeks for Geeks website, and we will study this in the theory part. Okay, so dynamic routing protocol, it's use op counts to use finding out the round matrix to find the best path between the source and the destination network, and it is a distance vector routing protocol, and AD value is 120, and it runs on application layer protocol of an OSI model and use the port number as 520. So 520, we said 0 to 1024 are well-known port numbers. It's used for various applications and various other processes. Right? 520 here is used for RIP. You should know this number and you should remember. This could be asked in your Viva. Okay, and op count is uh, used for the metric to find the least best path. Okay, and what was the maximum the up counts that can choose here in RIP16? Because since it was be a roaming protocol, so I will explain you why it is restricted for 16 up counts. I will explain you that later in theory part. There will be lots of problems, so that that's why, that means if you would not define this to be 15 or 16, so then your network will not be stable. What is the reason? I will explain you that in later. And there is something updates. The features of this RIPs are updates on the network are exchanged periodically, or always it's use a broadcasting, and full routing table are sent in an updates. Full routing table has been sent, and router always thrusts the routing information received from the neighbor routers. This is known as routing or rumors. Rumors ante ಹೇಳ್ತೀವಿ. Okay, there were three versions are available in this RIP protocol. One is version 1, version 2, and uh, NG, next generation RIP. This will be used in IPv6 version, and this is was earlier used, and nowadays we use version 2. Okay, what was the differences here? RIP version 1 is actually something broadcast message, but in RIP version 2, it uses a multicast address, okay, which is 224.0.0.9. It uses these addresses for the sending of its routing updates to its neighbor, okay. In RIP NG, it updates using multicast, and it is for IP6 address, and it is use a broadcast address, which is 255.255.255.255, and it does not support any authentications or of the updated messages. What do you mean by authentications? Since any of this net like router sends to updates to here, it will use and it will update that information in it. So somebody, I can simply inject that information on this network, false information on this network, so that as this device receives it, it will update. But actually it is in false information which I would send by my device. But knowing all these things, I can update that information, right? But that's what in version 1 it will be not there, authentication will not there. In version 2 something it will be authenticated. Okay, if you can give a password something, so that should be the same, then only it will be able to accept that kind of updates from the routers. Then there will be classful routing, and here it will be classless routing. Means it will auto summarize whenever you define a network address. Okay, so when I define 192 something, it will defaultly knows what will the subnet mask is class 24. When I define class B, it will know it is the subnet mask is class C. When I will define network address in class A, it will know the class A subnet mask. Okay, that is was classful routing addresses. But in IP address version, in RIP version 2, it will also support classless. It will not have a predefined subnet mask where you will be having an option to define the subnet mask there. So that I will see in some other class. Some other useful commands here: show IP route I already shown, and show IP protocol. So whenever if you want to know what is the routing protocol is running on this any of this router, if you would not knowing initially, you should give this command to know what is the routing protocol is running. Okay, if I give this do show IP protocol, do should use if you are in global configuration mode. should not use this if you are in privilege mode. You can see the routing protocol is RIP and sending an update for every 30 seconds, and next due is in 18 seconds. Means 80 after 18 seconds again this will be shared. Okay, and see there will be two interface, and what all the routing networks I defined, that thing, and routing information, all these things you would be able to see. And now I have to check what is the routing table. So IP route, you can see these three information actually I have learned from RIP. So what you, another thing you should know here, after this information you will see some two metrics, two values, 120 slash 1, 120 slash 1, 120 slash 2, and you can see the time. Okay, this time if completes again you will get the updates. Okay, so means what, a slash 20. Okay, 120 is actually tells the AD value. AD value means the trustworthiness of this routing information. This RIP will have the AD value is 120. So it will be defined from 0 to 255. Whichever having the AD value is less, that will be more trustworthy. Okay, means this will be an intermediate. It will not much trustworthy, or it will not even least, or it will not more trustworthy. It will be in between. If any of the routes, if you defined, okay, from here to here as static, so then it will take that route and they will not going to consider this route, because the route static or connect directly connected routes are more trustworthy and it has a AD value as 0. So you will comes to know more on this as you go with along with the next routing protocols. You'll comes to understand what is this AD value, and the next value what you would see here is the hop counts. So here it has a one hop counts for C. From this router to here it is only one hop. From here to 4 it is one hop. Okay. From here to 5 it is two hops, 1 and 2. Okay. So that is what this value tells. Okay. So this is all about your first one. And there will be see the same thing, configuration, everything you should do on the same part. Should go this diagram, and you can see all these tables also shown here for each of this router. After you doing this, you can use this command so that you would able to get this packets information, what are the exchange and everything in this CLI command. The next one is you change this address assign dot, here if it 8 means subnetting ಮಾಡಿರ್ತೀರಿ ಇದರಲ್ಲಿ 32 ಅಂತಂದ್ರೆ means how many bits were I changed, 6 bits to the power of 6. It is something nearly 64 subnetted, and each will be having a size of 4 addresses. Take this class address and assign one here and one here. You can see here for router 2, what is address I use, dot 9. For in another one is I use dot 10, and I use this was the subnet mask. That is also given. You assign and do the same way the configuration. Okay, but when I'm defining this on router 2, see I use the classless address itself. Okay, so class C it would comes, class C it would comes, right, 172 something. So all these are class C, but that will be class C, right? When I comes to class 2, here you can see it will takes the class C address, which is 4.0. There is another command we configure, passive interface on 0/0 fast ethernet means some interfaces you can make as passive. Since R1 do the broadcast, it would also send a packets to your LAN as well. Okay, here also I can make this interface as passive. If you made this interface as passive, this router will not going to send RIP updates on this interface, because here it might also connect another router, right? It will not going to see whether it connected to router, it connected to PC, or it connected with the LAN. It's simply broadcasted. Okay, it's simply broadcasted. So you can make wherever you not need the advertisement, you can make that interface as passive. So that is what I here it is defined. Passive interface followed by the, you can see in this configuration, passive interface and the interface name. If you give, that interface will not be, it will not send any of this routing information. That's it. Okay, that is another one. The last one is you configure these two with routing like RIP, and you use static routing on this, so that you would able to see the same thing. Okay, you try yourself, and every commands are given here. If you're not understood, you can ask me. The only changes have been shown highlighted in this point. part. Okay, is it clear? Is it everyone will do? Okay, and you can also see in this, and there will be timers. There is something called timers, and I will explain all these things. Not it will not require something here. I think for the next classes it might be needed. I'll explain in next class. Along with this is a one thing you first do. Along with this, another two programs you should do, because to finding out the least path, so you need some minimum span, like minimum distance calculation, right? For this RIP we use a protocol or an algorithm called Bellman-Ford algorithm. Okay, so for that we have to write a program, and we should know how to find a least path in a graph. Okay, we assuming this network will looks like a graph. Okay, the devices are uh, uh, like an vertices, and these links are edges. We connect like this, and we have to find the what will be the least path, or may a least path to the destiny each vertices. So for that we use a Bellman-Ford algorithm, and that is what we used in this routing protocol RIP, and we will do that in probably on Monday. Monday I will show you how to write a code for the distance vector, which is Bellman-Ford algorithm. Theory I will explain, as well as another one is distrust. For the next week lab, we should do this experiment RIP. Along with that, two programming, and that will I will give you in Monday. Uh, Bellman-Ford algorithm and distrust algorithm, where distrust are used in OSPF protocol, that will gonna explain in next class. No doubts. I will wait for 1 minute if you would have any